This lesson is on standard normal distributions. Suppose that you took a math test and a Spanish test. The mean score for both tests was 80, but their standard deviations were different. The standard deviation for the math test was 4, and the standard deviation for the Spanish test was 8. You can assume both distributions are normal. You got an 86 on the math test and a 90 on the Spanish. If you were to compare yourself to your classmates, which test did you outperform your classmates more? Use a sketch of the two distributions as part of your explanation. Let's use the mean and the standard deviation in order to draw our distribution curves. On the math test, I got an 86. On the Spanish test, I got a 90. Based on the location of the score on the normal distribution curve, I did better on the math test. I know this because on the math test, I am 1.5 standard deviations above the mean, whereas for my Spanish test, I am only 1.25 standard deviations above the mean. Because my score for math is more to the right of the normal distribution curve, there is a larger population of students who scored lower than me. The standard normal distribution is a normal distribution with a mean or mu of 0 and a standard deviation or sigma of 1. The z-score formula is z equals x bar minus mu divided by sigma divided by the square root of n. The z-score tells us how many standard deviations a value is from the mean. We'll also identify what all the variables represent. X bar represents the mean of a sample. Mu, which also is a mean, but it is our population mean. Sigma represents the standard deviation of our population. And lastly, n represents our sample size. On a standard normal distribution curve, we have a mean or mu of 0. We also want to identify all the standard deviations away from the mean. So this is 1 standard deviation away, 2, 3, -1 standard deviations, -2, -3. Because all normal distributions can now be turned into the same standard normal distribution curve, we can use calculus to find the area under the curve of any normal distribution. This means that we can find the probability of any data value, not just within a certain number of standard deviations. This means that we would be able to answer all of the questions from last class with our ACT example. For example, we would be able to answer the exact percentage of students that scored below 16. We would be able to know if Calvin was within the top 1% of student applicants. However, let's note, because we haven't yet studied calculus, we will need to use a table. This is the z-score table that we will be using for our class. It is one of many types of z-score tables. It is not the only one. However, it is the one that I will be using in all the examples that we go through. Example 1. You recently bought a printer for $340 and would like to compare it to all the printers in the store. The prices of the printers in that store have a mean of $240 and a standard deviation of $50. A. What is the z-score for the price of your printer? So we know the z-score formula is equal to x bar minus mu divided by sigma divided by the square root of n. So based off of the example, let's identify what our variables are. We bought a printer for $340, so this is going to be the mean of my sample. I would like to compare to all the printers in this store, which has a mean of $240. So this is going to act as my population mean. My standard deviation is sigma, $50. And lastly, what is n? N is going to be equal to 1 because I happen to only have one printer for the cost of the $340. So what does a z-score of 2 represent? It represents how many standard deviations a value is from the mean. So to answer letter B, how many standard deviations above the mean was the price of your printer? The printer is 2 standard deviations above the mean. C. Your printer is more expensive than what proportion of printers in that store? What I'm trying to do is find the area under the curve that is below 2 standard deviations from the mean. I can use my z-score table to answer this question instead of using the empirical rule. Going back to my z-score table, how I would read this, I would essentially just find 2 standard deviations by going down to find 2 in the first column. And since it is exactly 2.0, 2.0, I'm finding the intersection, which would happen right here, 0.9772. The area under the curve would be 0.9772. D. Your printer is less expensive than what proportion of printers in that store? It is less expensive than the area under this curve. Since I already know that the area under the curve below 2 standard deviations is 0.9772, I can say the entire area is going to equal 1. So 1 minus 0.9772 would be the remaining portion above 2 standard deviations, which is equal to 0.0228. Example 2. Ashish's height is 63 inches. The mean height for boys at his school is 68.1 inches, and the standard deviation of the boys' height is 2.8 inches. What is the z-score for Ashish's height? Ashish's height is our sample mean. Because there's only one number, we know that n is equal to 1. 68.1 inches is the population mean, and the standard deviation for the boys' height is our standard deviation of our sample. Therefore, the z-score is equal to on a normal distribution curve, where would Ashish's height be? If he has a z-score of negative 1.82 and we know that the mean is going to be at 0, that would be negative 1.82 standard deviations away from the mean. Explain how his z-score relates to the number of standard deviations. Like we previously said, Ashish's height is 1.82 standard deviations below the mean height. In this z-score table, we don't have any negative values, but we know that we have a z-score of negative 1.82. We're still able to use this table to figure out what proportion that would be. I'm going to find 1.8. 2, the intersection is this cell at 0.9656. That would be the area of the curve for all values below 1.82. So if this is 1.82 standard deviations, this proportion, which is the area under this part of the curve, would be equal to 0.9656. However, since I know that normal distribution curves are symmetric, negative 1.82 would also have a proportion of 0.9656 for the area under the curve above negative 1.82. So I'm going to use this information in order to answer the remaining questions for example 2. In this normal distribution curve, I know that 0.9656 of the boys at his school will be taller than him, and 1 minus 0.9656 will be the proportion that is shorter than him. Example 3. The U.S. Department of Agriculture, in its official food plans, states that the average cost of food for a 14 to 18-year-old male is $261.50 per month with a standard deviation of 16.25. Assuming that the monthly food cost is approximately normally distributed, find the probability that the monthly food cost for a randomly selected 14 to 18-year-old male is A. Less than $280. First, identifying all the important information. $280 will be my sample mean. My population mean is the $261.50. My population standard deviation, and a randomly selected 14 to 18-year-old male means that our sample is 1. For a z-score of 1.14, going back to our table, 1.14, finding the intersection, would be 0.8729. E, more than 270. Going back to our z-score table to find 0.52, 0.52, the intersection would be the cell 0.6985. Now reading the question one more time, it says more than $270. We found less than $270, so to find more than, we would take 1 minus 0.6985 and find that it's about 0.3015. Please go ahead and answer C and D on your own, and we'll continue that in conference tomorrow. Please try example 4 on your own and pause the video at this time. Please go ahead and check your answers at this time for example 4.